All right, welcome. And welcome to the section that everybody shivers at, right? IPv4. We're going to do it differently this time. Instead of telling you, hey, this is the class A, this is the class B, I will tell you all that information. But right from the get-go, let me just tell you how this is done. Now, there's a great website, which I have already up here for you. It's subnettingquestions.com. They don't tell you how to do it. They just give you questions so you can practice and practice and practice and practice. All right? But I want to explain it to you. That's why I have the notepad that's open right here. And I put the bit values, 128, 64, 32, 16, 8421. That is the bit values for each of the bits, right? The 8 bits that's within each octet of an IP address. All right. So how do I do it? How do I attack a question? I can care less what they give me here to a certain degree. What I focus on is the subnet mask. The subnet mask. So I'm looking at 23, a slash 23. So what do I do immediately? Well, what I do, let me go to Notepad. I'm going to hit enter. And I will get out of the way just in case I'm in the way. Well, let me do it over here. All right. And then I go, okay. So X, let me put it in caps. X.X.X. Oh, it's 23. Sorry. It's 23. So I got 16, 17, 18, 19, 20, 21, 22, 23. Then there's a line. 0 makes 24. 1, 2, 3, 4. 1, 2, 3, 4. So right here, that's what that 23 means. That your line is in the third octet. That means this is the interesting octet. This is where you're working at. All right. So the bit values, that would mean that this line really is here. Okay. So that bit value to the left, which is this one right here, well, that is your network increment. So you need to increment by 2 until you get to 116. Whoa, that's a lot. That's a lot. I don't want to, man. Okay, that's incrementing a lot. Is it not 2, 4, 8, 16, or 10, 12? I'm not going to do that. So I'm going to pick a number that I can multiply by 2 that will get me close to that. Well, let me see. 50. What's 2 times 50? That's 100, right? Well, can we get closer? Well, I mean, that's good. 100. So we got 100. Well, no, let's get a little bit higher. Let's say what? 52. Let's assume 2 is 4. 25 is 10. It's 104. Then we got 106. Then we got 108. All right, let's write these down. Let's write these down so we know what we're talking about. I took a number that I can multiply by 2. Now, the numbers that I'm going to put here, so not to put x.x. whatever, is just the third octet, because the third octet is what we're working in. So I took a number, let's say 50, just to say 2 times 50 is 100. All right, so 100. Then we got 102. Then we got 104. Then we got 106. Then we got 108, because we're in the third octet, yes. We got 10, 1110, 1112, 1114, and 1116. Well, and then we go one more, 1118. So, okay. So 1116, that's the number we're looking for. Okay. What is the first valid host on the subnetwork that the node, this particular IP address, right, the .75 address, belongs to? Well, check this out. We're working in 2 octets. Yes? Yes, we are. So if we go here, and I want to space this out, we have x.x.117.255. That will make this 118. So what will be the first value right after 116 dot whatever? Okay, so that will be, and I'll bring it right over here. This will be the valid range. So this will be x.x.116.1 through x.x.116 or 117, I should say, .254. And let me bring this back in so you can see it. So we have our network address, which is 116.0, and then we have immediately after that 116.1. And then we have all the way up to 117.254, that's the valid range. And then we have 117.255. That's it. That's it. All you got to pay attention to is that subnet mask, right? Where you draw that line so you know what bit value, in this case 2, you're incrementing by. You're increment, and you do it. And the way we did it this time, since it's a very low bit value, like let's say if you're doing it by 2 or by 4, even by 8, right? You can go ahead and do 2 times a number, 4 times a number that gets me close to whatever value or in the octet that I'm working in, and you'll be just fine. That is the key. That is the key to subnetting. That is the key to wildcard masking. That is the key to everything. All right, because this little thing right here, what's a subnet mask? 255 all on, 255, 254.0. How do I know it's 254? Because I add all these guys, right? Ooh, look at that. You just moved it all over the place. Okay, I add all these bit values here. It gives me 254. All right, if it's all 8 on, and I'll show you the table in a bit. This is 255, 255, 0. Well, what's the wildcard mask? And you'll learn how to do that. Well, 0, 0. And then we have here is 1, correct? This is bit value 1. So it's x.x.1.255. But I'll show you 2 ways of doing that when we get into wildcard masking. Very simple. It gives you the number of networks that you can have and the number of hosts that you can have. So this little formula, if you want to call it that, this little diagram, it will help you tremendously. Your focus is the subnet mask. Take a look at it. Find where you draw a line. See by what number you increment, what octet you're working in, and then don't go over that number if you do, like I did here, but just to go 1 less, and then I know my range. That's the secret to all this. That's it. It's not a secret. It's very simple. So we're going to start getting into, again, this is just an introduction to IPv4, telling you it's very important. Not only is it important in your Cisco exam, I've gotten this question from students, like, hey, Laz, what is the percentage of IP addressing questions that you get in the exam? Well, according to Cisco, it's only 5%. But if you're a network technician, a network engineer, a help desk person, a computer person, period, if you don't know how to IP address, subnet, summarize, VLSM, anything that has to do with IP addressing, if you don't know how to do it, whether it's in version 4 or version 6, man, you're not going to make it in this world, okay? Unless you always have a calculator next to you, which is sometimes the reality of it. But it is so simple, especially with IPv4, all right, that you can do it in your fingers. Hell, you got 10 fingers. All you need is 8 bits, right? So this is all you need, okay? And this is exactly how I do it. Boom, 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 right? But for your certification purposes, it's not going to be that difficult. It's going to be pretty simple, pretty straightforward. All right, so IP addressing is extremely important because without IP addresses, you can't network. What are you going to do? You're going to have an APIPA, and we'll learn what that is in a bit, an automatic private IP address to network? No, they're not routable addresses, okay? And they're not going to get assigned automatically. What are you going to do? You're going to statically assign everything? You're going to create a range on a DHCP server for an APIPA? It is a reserved address. So definitely you don't want to do that. You need to learn how to IP address. It is not physics. It is not physics. You need to pay attention to me. If you still have problems after what we go over, I do have a book on Amazon, okay? And I have it somewhere down here. I'll show it to you throughout the course. You can go ahead and purchase it. Everything you need to know about IP addressing, all right? It's right there, all right? So you can go ahead and purchase it. If not, I'll show it to you in the next lecture. I'll show you the book, all right? But if anything, it is in Amazon. You can get it. It's the only book, that's the title, that you showed it to me. It's the only IP book you will ever need. It's the only IP book you will ever need. It's in Amazon. If you still have issues, after watching the video over and over again, you still say, man, I have no idea what this bald guy is saying. I don't know. Get the book. All right. Everything is there for version 4 and version 6. Okay. That's the only thing. But you're going to see, just like I just did this question, this website is awesome. It won't explain anything. But after you learn how to do it, then you can go here and you'll get question after question after question after question after question. So you can practice and practice and practice and practice. And we all know practice makes perfect. All right. So again, this is just a little brief introduction. into IPv4 addressing. Get ready, because here we come. All right. So I gave you the answer already on how to actually subnet, really. All right. But what will be that the trick, right? That everybody knows it's like a secret. No, it's not. All right. So here, let's go ahead and start doing the stuff that we normally do. We know what an IP address looks like. There you go. You got your 192.168.1.17 CIDR 28, 172.16.16.1 CIDR 20, and 10.16.1.1 CIDR 12. Why am I picking those CIDRs? They have something in common. What is it? We'll soon find out. But just know that this is Cisco's favorite CIDR. These CIDRs you see up here, they love to use it. You'll know why in a second. We also know that, or we will know after now, that an IP version 4 address is 32 bits. Why? Because it's 8 bits per octet, all right, and it's separated by a decimal. Now, there's new terminology, right, that they've put in here. Now we need to memorize this, okay? Before, this was, dotted decimal addressing. Now it's called dotted decimal numbering. All right. So major change there. So make sure you know that that's the what they call it now, dotted decimal numbering. Okay. Especially when it comes to the subnet mask, because that's what they're talking about. All right. Another thing, the subnet mask. And I've had this argument, discussion, whatever you want to call it, for years upon years. The mask, the subnet mask, does not make the type of address. It has nothing to do if it's a class C or a class B. Here we have a 20 and 12 because I wanted to use what Cisco likes to use. But I can have a 28 with a class B. I can have a 28 with a class A. That doesn't mean it changes the class of address because you have a different mask. Okay? So the mask has nothing to do with the class of address that you're using. All right? This means, though, that this is a subnetted class C address. This is a subnetted class B address. And this would be a subnetted class A address right here. That's all that means. All right? Do not, I'm saying it again, the subnet mask, the CIDR, the dotted decimal numbering has nothing to do with the class of address. Anybody that tells you so, you tell them to shoot me out an email so I can teach them something. Okay? Now, we saw this before in our previous lecture. All right? Which is, hey, wait a minute. Where am I? Oh, right here. This is your bit values. That means per octet in each octet. All right? The values from the high order bits to the low order bits, right? It's 128, 64, they're always the same. They don't change per octet. They remain the same. They don't change. Okay? What changes is underneath, because one of the things that people tell me, Laz, what do you count on top and not on the bottom? All right, my finger's not working today. All right, I had to reprogram it. Okay, so when I have an address like this one, and let me space it down just a little bit. Enter, enter, enter. Okay, when I say bit values, I'm talking on top of the address. That's how I put my bit values, on top of the address. So in this octet, you have those 128, 64, 32, 16, 8, 4, 2, 1. Because these are the numbers that become 192 or 224 or whatever it is here is by turning on and off these bit values. So these bit values exist in each octet. Okay? On the bottom, you will see that is where I count. If I'm counting from left to right, I'm counting for networks. If I'm counting from right to left, I'm looking for host. All right. So keep that in mind. I'm stressing it. I've raised my voice a little bit. I hope I don't scare anybody off. Okay, because I did so. So those are bit values, and they will help you throughout subnetting. Now, this little table right here, man, is this ever a lifesaver? All right. This is something that you should write down when you go take a certification. You should write it down so you don't have to think. All right. So you can just go, beep, that's what it is. Beep, that's what it is. All right. If you have one bit on, meaning 10000 like this, okay, this is a 128. What will be an example? Let's say you have this right here. Make it a simple example. 255.255.255.128. Okay, that means they're all on 128. It means there's one bit on in the last octet. Or it could be right? All on 128, nothing on in the last octet. That's all that is. So that's what that's telling you. Okay? The same thing goes to the second one. We'll use the same example. All right? It could be 255.255.192.0. It could be just like that. So 192, what's 192? 192 is 2 bits. Oh, this is where I draw my line. That's how you use that. So you can draw your line. All right, so you know where to draw it, how many bit values are on. All right, 3 bits, 224, 4 bits, 240, 5 bits, 248, 6 bits, 252, 7, 254, 8, 255. You need to memorize this. You need to know on the top of your head. All right, but if you can't for whatever reason, write it down before you put it in. And remember, when you walk in to take your certification, you're walking into a sacred room. You're walking into a room where nothing is allowed. All right, but what they give you. All right, so remember that. So keep this, memorize this, because this is definitely going to help you. All right, now we're going to get into CIDR to dotted decimal notation. It's the same thing. We have a CIDR 12. We have 12 bits on. All right, so what does that mean? Okay, let me put it right here. So we got 8 and 4 is 12, right? 9, 10, 11, 12. Okay, so that means the first 8 are fully on. So that's 8. It's fully on in the first octet. There's my period. That means I have 4 that's on in the second octet. Well, wait a minute. We have 255 because there's 8 bits that are on. Well, yeah, 8 bits. Then we have 4 bits on. That makes 12, doesn't it? Then the other 2 are off. So how would that be? Well, what's 8? 8 is 255. Well, what's 4? Well, 4 is 240. The other 2 are just off. That's it. Well, Laz, what's so important about that? Well, because sometimes you're not going to get a CIDR 12 where you just count 12 bits in and draw your line. Sometimes they're going to give you something like this, a dotted decimal number. All right, and then you need to know 240. How many bits does it take to be a 240? So I can draw my line. And you know what your bit value is. This is where the table comes in. All right, let's do the 20. So we got 20. So we got 8. Then we got 16. Then we got 20. 8 and 8, 16. 4 is 20. So that means the last one is 0. Oh, okay. So that means we got 255. Dot 255. Dot how many bits? What's the value of 4 bits on? 240. Dot 0. You see how it's coming together? I hope. Okay, then 28. Same thing. 8 bits on, 8 bits on, 8 bits on. That's 24. 4 more bits. That's 28. So what does that mean? 255.255.255.240. Let's bring this all the way to the top here so you can see it. So what is that you're noticing? They're all 240s. That's why Cisco loves this. Why? Because they all increment by 16. 16. So another thing that you should write when is your incrementation of 16. Now, I will make it available to you in your handouts. Just sit down before you start because you know there's a survey. And you go 0, 16, starting at 0. 0, 16, 32, 48, 64, 80, 96, blah, 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 all the way to get down to 240. All right, increment for the 16. All right, by 16 before you start. So when they ask you a question and you know you're incrementing, is it 240? When you see 240, you know you're incrementing by 16 in whichever octet. The last octet, the fourth, the third, the second, it doesn't matter. Your incrementation is 16. And that's why Cisco likes it. Anyway, so I gave you some handy tables that you can use. Okay, definitely. We know the format, we know all that, but knowing your bit to decimal table, knowing your bit values, and how to convert from a CIDR to a dotted decimal using this particular bit table, doesn't want to work here, using this bit table to change it to the dotted decimal is very simple. Not that you have to do it. They're not going to give you, all right, you have a CIDR 12. What is the dotted decimal number for this CIDR 12? They're not going to do that. But they're going to give you an IP problem, and it may be in a dotted decimal numbering fashion. You need to know where to draw that line. This is where that table comes in. All right? That's it. Very simple. This is the breakdown of what an IP address looks like, right? Or what a subnet mask may look like. And you need to know this because you need to know which network you're in. And the subnet mask is going to tell you what network you're in. All right. Enough said. I'll see you in the next lecture. All right. Welcome back, everyone. Now, we have to know this, so I got to say it. All right. Especially for new students that have never done this before. All right. Classes of IP addresses, and we're going to get into private IP address range as well. All right. How do we classify an IP address? I said that the subnet mask does not make the class of address. So how do you know what class of address it is? We identify the class of address in the first octet. Whatever number is in the first octet, that is the class of address. Well, okay, so what's that number? Well, this is why we have a range. If you're in a class A, the range will be from 1 through 126. That means if you see in an IP address in the first octet, which is all the way to the left, okay? If you see a range between 1 through 126, then that is a class A address. The default mask is this. Not necessarily it has to be that. The default, and careful when answering questions on any type of Network Plus or CCNA certification, all right? If they ask you for the default mask, then you would say 255.0.0. If they just ask you for, what mask are we using? Oh, we're using a 28, a 24, a 17, whatever. Because it doesn't matter the class of address, again, to have whatever mask. Okay? All right. So a class A, you identify an IP address, an IPv4 address, by the first octet. So again, a range of 1 through 126, that would make it a class A. This would be the default mask of 255.0.0.0, and it can hold 16,777,216. This is before we minus 2. It would actually hold 214. So just take away 2 from each one of these, and that will be the exact number of IP addresses that it would hold. But this is in its entirety, 256 addresses. We subtract 2, plus the network ID and the broadcast address, right? On the host side. Network ID, broadcast address, we take away 2, this is a 214. But that's the entire number of IP addresses that fall in there. Now the next class is B. So if in the first octet, you see a range of 128 through 191, that makes it a class B address. We're dealing with a class B address. So if you see a 128, a 130, a 171, a 172, a 190, hey, that's a class B address. Therefore, its default mask will be 255, meaning first 2 octets, don't mess with, 00. The last 2 octets are off. And how many IP addresses can you have? Well, in its entirety, once again, 65,536. But what do we need to do? Subtract 2. Why do we take away 2? Because network ID, broadcast address. We can't use those. We cannot assign it. All right, because it's a class B address. It will not allow you. So we take away 2. You're left with 65,534. I think that's enough. All right. Anyway, next class of address we need to know 192 to 223. So again, first octet, anything in that range is a class C address. Default mask of a class C, 255, 255, 250, and it can hold up to 256 minus 2, meaning only 254. Remember, always on the host side, you take away 2. Always on the host side, you take away 2. All right? So really, this would be 214 up here. This would be 34, and this would be 254. All right? Or 534 and then 254. Okay? These last two here, Class D and Class E, we still need to know how to classify them. You already know by looking at the first octet, if they're falling in whatever range, that makes it a D or an E. The D doesn't have a default mask and doesn't have a default number of hosts. Why is that? Because these are special types of addresses. Normally, any book will tell you, well, this is a multicast range. We use it when we're doing IGMP, we're doing web conferencing, things of that nature, video conferencing. We're just going to create a private network within this particular infrastructure, so we'll use this range of address. That's true, but what's also true and what you need to know, and I'll put them when we get into the routing portion of the course, the multicast addresses for your routing protocols. That is what you need to memorize. That is what you need to memorize. 224.0.0.5 or 6 for OSPF, 224.0.0.9 for RIP, 224.0.0.10 for EIGRP. Those are the ones you need to memorize because that is what these routers use to send the update across to their neighboring routers. Those are the important addresses. Don't worry about that, writing it down now. You can rewind, pause me at that point, write it down, keep going, so forth. But I'm going to give it to you anyway when we get into the routing portion of the course. So here, yes, is a multicast address range, but we're more interested in the fact, for certification purposes, we're interested in the fact that, hey, we're using this 224 to send our updates from our router. Okay, this one, 240 to 255, honestly, no book talks about it. All it says is experimental. Black Ops, I don't know. Who knows? They use it to check stuff. I have no idea. All right, so we don't use this. All right, experimental. That's all you need to know. Experimental. All we use really is from Class A to Class C. And just so you know, don't you find something weird here? Where's the 0? Where's the 127? They're not there. Why? Because 0 is reserved. Okay? 0 is a reserved address. We use zeros for, default routes, all right, for many things, all right? So 0 is not used. 127, we all know, or should know, that is reserved. The entire 127 range, meaning 127.0.0.1 for 127, 255, 255, 254, it's all reserved for loopback. So you can ping any one of those addresses anywhere in there, 127, 12, 38, 200, and you'll get a reply. If an octet there. If your TCP/IP suite is working, that is what the loopback address is checking. If your TCP/IP suite is working, you're not testing your NIC card with that, okay? You ping your NIC card, whatever IP address you put in there. But your TCP/IP suite, that's what you're testing when you ping 127, all right? Now we're going to get into the private range. The private range. So a couple of guys, the powers that be, they say, whoa, we're wasting IPv4 addresses, public IPv4 addresses, right? So we need to say, okay, we're going to take out a chunk of the first 3 classes, and we're going to make them private, meaning they can't get on the internet with these addresses. They can use it internally in their network, okay? So they say, okay, we're going to get a class A. You know what? The whole class A. The whole class A, we're going to give them all 16 million addresses for the class A. They can go ahead and do whatever they want internally using that. So anytime you see a 10, that is a private IP range. For B, 172.16.0.1 and 172.31.55.254, that right there, hey, that is your private class B. If it says 15, it's public. If it says 32, that's public. If it's 16 through 31, that is private. Private IP range. Private IP range. All right, and then the last one is your Class C address, 192.68.0.1 to 255, 254. And obviously, we're using the default masks that we already know of, okay, for each one of these class of addresses. And this is what you would use. Caution. Caution. And I've seen this happen already, and I've mentioned in many other courses and many other lectures, okay? Please, when you're creating a network or you're walking into a network, okay, see what their IP scheme is, one, if it's already made. And if not, if you're creating this from scratch, do not just say, well, we have 6 computers, we're just going to subnet and just allow for 14 computers. That's it. Don't do that. Think of growth, of expansion. This company could overnight decide to have branches all around the world, and now you're going to have hundreds and thousands of IP addresses. Leave yourself room to grow, okay? Leave yourself room to grow. Don't get stuck. Why not use a Class B? So what if you only start with 6 computers? Use a Class B, all right? I'm not saying to use a default Class B, but use a Class B address that will give you the room to expand as you grow, okay? As you grow, and you won't fall into it, because I've seen companies, not small business, but companies that did not realize their potential, all right? And they grew exponentially, and they ran out because the person that did the network decided to use a private IP addressing scheme, or C. And now it's like, hey, I have no more networks. Oh, what do you do now? Okay. Well, there's many things you're going to do, but they're not going to be nice, whichever ones you want to do. All right. So make sure when you're creating a network that you have enough addresses available for growth. If you have 6 computers, you don't go buy a 12-port switch. Buy a 24-port switch. Buy a 48-port switch. What do you care? Okay. Plug it in. You never know what's going to happen. Okay. You never know what's going to happen. So you have the room to grow. All right. But there you go. Those are your classes. That's how you classify an IP address. And this is your private IP range. I'll see you in the next one. All right, welcome to the summary of this particular lecture, but do not think that we're done with IPv4. Not at all. All right. In this section, we discussed the basics of IPv4 addressing, its format, right? The 32-bit, 4 octets, each one, it's 8 bits due to the fact that it's an octet, right? The bit values, they're the same in each octet, how we count for networks, how we count for hosts, okay? The very first thing we did is I showed you how to friggin' subnet. What is the secret, right? To look at just the subnet mask. All right, we learned how to go from CIDR notation to dotted decimal numbering, the new terminology, dotted decimal numbering, right? Not dotted decimal addressing, dotted decimal numbering, okay? And we now know how to classify an IP address, and we know the private, which I did right now, the private IP addressing scheme, right? Which is from A, B, and C. So we talked about those things. And those things, even though that you may think, oh, that's just basic stuff, but you need to know, because you never know. You may be that individual that get asked, what is the range of a Class C private IP address? Man, that's highly doubtful. I wish they would ask you stuff like that, but they're highly doubtful they will. All right, but at least you need to know. Because if you go out there, and I do it too, when I go to hotels all the time, I just do that. Plug in my computer, go to command prompt, do an IP config, and I see what class of address they're using and what subnet mask they're using, just to see, just for the heck of it. Okay, because that's just the way I am. So curiosity. You need to know when you're looking at a computer, you're networking, you're looking at the IP issue, you need to know the class, the type of IP addressing that you're actually looking at. Okay, you need to know this. All right, so, and this is what we did here, basically. All right, converting back and forth and understanding what type of address we were looking at and why some are used and some are not, like the APIPA, the 169.254.0.0 or whatever, XX, you can put whatever in the last 2 octets, but the 169.254, That's your repeater. The 0 is not used. The 127 is not used. They're reserved addresses. These are things that just basic understanding that you need to know about IP addressing when you're out there networking, troubleshooting, and most definitely when you're taking your certification. All right, that you need to understand what you're looking at. All right. With that said, I'll see you in the next one.